Okay guys, so we are now on day 2 of composite figures. So again, we're going to take a figure and break it down into shapes that we know how to find the area of. And we're going to make sure we have our formula chart so that we are using that. So this problem here says ships in a first generation video game were modeled like the one below. How many square inches of the video screen did one ship occupy? So right here, square inches is telling us that we are looking for area, okay? So area is square inches, and we're looking for the area of this one ship. So we want to break it apart into pieces that we are familiar with finding the area of. So I see up top, I see a rectangle. Okay. So I am actually going to use colors because it's easier for me to see. So I encourage you to do that as well. So we're going to do a rectangle. And then down here I see, looks like a parallelogram to me. So these are two fairly easy shapes to find the area of. I write my parallelogram. And draw my little picture so I don't forget. Okay, so I'm gonna now look at my formula chart and find the formula for a rectangle. So my formula chart says that for a rectangle, area equals BH, so base times height. So I'm gonna go here and let's see, I don't see a dimension for base. So what I know is that the top of this parallelogram is going to be equal to the bottom of the parallelogram, right? So 3 2/5 is going to be this piece plus these two. Okay, so I know that I have a half here and 1/2 here. So 1/2 and 1/2 makes a whole, right? So that's 1. So I'm just going to do 3 2/5 minus 1. So that's 3 minus 1 is 2. So this dimension here is 2 2/5. So again, I went ahead and took a half and a half and I made a whole. Oh, goodness gracious. Sorry. Okay. So if you're still confused, we know that 1/2 is 0.5, right? It's like 50 cents. So 0.5 plus 0.5. Oops, it doesn't want me to write there. Is like 1.0, right? So 3 2/5. So if you think about 2/5, if the bottom number is a 5, we think about $20 bills. So 20/40. So that would be 3.4 minus 1.0. Okay, 3 minus 1 is 2. So 2.4 or 2 2/5. So that's how I got this dimension right here. Again, I knew that this half plus this section, the bottom of the rectangle, and this other half would be equal to the bottom of the parallelogram. Okay, so now I have the base of my rectangle. So I have 2 2/5 times the height of my rectangle. So my height is 1 1/3. And I know here that 1/3 is a repeating decimal. So I don't want to change that into a decimal. I have to keep it in fraction form. But to multiply fractions, I need to go ahead and change it to improper fractions. So I'm going to do Texas. So 2 times 5 is 10. 10 plus 2 is 12. So I have 12 and I keep my denominator, 12 over 5, times 1 times 3 is 3. 3 plus 1 is 4. So 4 over 3. And then I can go ahead and multiply across. So as well as I can take common factors out of the diagonal. So I could take 3 out of these diagonals and make it a little bit easier. I know some of you struggle with that. So I will go ahead and multiply across. So 12 times 4 is 48 over 3 times 5 is 15. So I'm going to go ahead and leave that here because I know to find the total, right? I want the total area of the ship. I'm going to have to add this rectangle to the parallelogram. So let's just keep it as an improper fraction for now to see what we're dealing with the parallelogram. So now I'm going to look at my formula chart, and I see on the formula chart that area equals base times height for a parallelogram as well. So I'm looking at the base here, so 3 2/5 times the height. Now remember, height is always going to be at a 90-degree angle, so times 2. So I'm going to go ahead and just change this into an improper fraction as well. So 3 times 5 is 15, plus 2 is 17 over 5 times 2 over 1. I'm going to change it into a fraction. So 2 times 17. I'm going to go ahead and do this over here to the side. 2 times 7 is 14. 1 times 2 is 2, plus 1 is 3. So I have 34 over 5. Okay, so now I need to go ahead and find the total, right? So to find the total, and I like to put these amounts in here. So this is 34 over 5. And this here is 48 over, which doesn't completely help us right now because the fractions look so different. But anyways, now we need to go and find the total, right? Because I want the entire ship together. So total. So I need to add 48 over 15 to 34, I'm adding over 5. So to add fractions, you need a common denominator. So I can't make 5 15, but I can make I can't make 15 5, but I can make 5 into 15, right? So 5 times 3 is 15. So I'm going to multiply the top and the bottom times 3. So 5 times 3 is 15. Now I just have to do 34 times 3. 3 times 4 is 12. 3 times 3 is 9, plus 1 is 10. So I have 102 over 15. So now I'm just going to add across, and I keep my denominator. So I'm going to do 102 plus 48, 8, 9, 10, 4, 5, 150. So I have 150 over 15. So some of us may know what 150 over 15 simplifies to already. If not, you can go ahead and divide. 150, top in, bottom out, right? Divided by 15. Well, 15 goes into 15 one time. We have no remainder, but I have to get to my decimal point, right? So my answer is actually going to be 10 inches squared, okay? So this one looked tough at the beginning, but we were able to get there in the end. Okie doke. So now we're going to move on to this second problem. And again, I really do encourage you guys using colors. That way we can go ahead and easily separate the figures. Okay, so Gretchen draws a pattern to help construct a bow for her sister's doll. How many square centimeters of material does Gretchen need to construct 3 bows for her sister? So how many square centimeters? So again, that's telling us we want the area, and it's saying how many square centimeters to construct 3 bows. Okay, So let's see, what shapes do we see here? So I see, looks like 3 different shapes to me. So I see a trapezoid here, but it looks like an equal trapezoid over here. Okay, and then I see a rectangle here in the middle. Okay, so I'm going to go ahead and start with my rectangle. So for a rectangle, use my formula chart. I know that area equals base times height. So the base of my rectangle is right here. It's 4. My height is 6. So 4 times 6 is 24. So that one was easy peasy. I'm going to write it in here. So now I'm going to go to my trapezoids. So it's saying here, this little line here and here are telling that these 2 sides are equivalent. Okay, so trapezoids. I draw my little picture so I don't forget what it looks like. So on my formula chart, I see area equals 1/2 base 1 plus base 2 times the height. And I know that base 1 and base 2, the order doesn't matter because we're just adding. So I'm going to keep my 1/2 because always I'm writing my formula first and then I'm substituting in for the letters. So base 1, I'm going to go ahead and say this is base 1. So this is 10 and it's 2 trapezoids. I'm not going to forget that. Okay, so 10 is base 1. And then base 2 is going to be this part 2. And I know that these are the bases because they're parallel, right? The bases of trapezoids are parallel. So base 2 is 6. And now I need the height. So I know that the height is at a 90-degree angle, and I see that here with 5 centimeters, not with 5.4. So I'm going to do times 5. So 10 plus 6, so 1/2, 10 plus 6 is 16 times 5. I'm going to go ahead and simplify. Half of 16 is 8, and 8 times 5 is 40. Now that is 1 trapezoid, right? But we have 2 trapezoids. So 2 times 40 equals 80. So I'm going to go off over here and I'm going to do my total, right? So my total is 24 plus 80. So 4, 8, 9, 10. So my total is 104 centimeters squared. So is that what the question's asking for? It says how many square centimeters of material does she need to construct 3 bows? So we have 1 bow, right? Equals 104 centimeters squared, but we want 3 bows. Sorry, not cubed, squared, going crazy. And my goodness, it just wants to move it. This is ridiculous. Okay. So now I'm just going to multiply times 3 because I want 3 bows. So 104 times 3, 3 times 4 is 12. Bring the 1 down, 1 times 3 is 3. So 3 bows need 312 centimeters squared of material. Okay. All right, guys, so these are a little more complicated, but we need to make sure that we have a good understanding of these problems going into our common assessment next week. So now we're going to do a partner practice problem next.